Hey everyone, for this video we're going to talk about the properties of equality and how to use the properties of equality to complete a two-column proof, as well as any other reasons we can use to complete a two-column proof. In this video we are going to be focusing on algebraic proofs. We will move on to geometric proofs later in the lesson. So go ahead and make sure you follow along, and we're going to go ahead and get started. Now, the first thing you may notice is that my version is ever so slightly different from yours as usual. The one I give to you guys does not have the wonky fonts. So we're going to go ahead and stick with this. Properties of equality. On your copy, I did tell you that this is mainly just saying that what you do to one side of the equation, you must do to the other side of the equation. So we have various properties of equality. We have the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. These are all pretty much the same. They are going to be variations of the same rules. So they're all going to start if A equals B. So if A equals B, every single one of them starts this way. So what I'm going to do is real quick, I'm going to add that to each of these. And then I can. So for addition property of equality, it's if A equals B, then if we add the same thing to both sides, it'll still be equal. So A plus C is equal to B plus C. So we're just adding C to both sides to maintain equality. The subtraction property of equality is very similar in that instead of adding, we're just going to subtract. So again, we're going to subtract C from both sides. So if A equals B, then A minus C equals B minus C. These are just the rules that we've used for solving equations. The multiplication property of equality, if A equals B, then A times C is equal to B times C. Again, we're just multiplying both sides by C here to maintain equality. And then finally, division property of equality. If A equals B, then A divided by C is equal to B divided by C. So they're fairly simple rules. We've been following them all the time since Algebra 1. However, now we're putting a name to it. The next property we're going to talk about is the distributive property. You guys are already familiar with this. You use it all the time. Remember, distributive property means we're going to multiply everything on the outside by everything on the inside. So if A times B plus C, then A times B plus C is equal to AB plus AC. Right, our substitution property, again, this is basically just everything we've done for the last several years. If A equals B, then A may be replaced by B in any expression or equation. We're just going to substitute. So remember, if I have a substitute, that means there's another teacher replacing me. So if A equals B, then A may be replaced by B in any expression or equation. Our reflexive property is the one that I affectionately call the duh property. It says for any real number, A equals A. A value is always equal to itself. And again, I know that feels like it should be self-explanatory, but we have a rule for it, and we need to include it in our proofs when we are getting to the end of them. Usually. All right, our symmetric property, again, is one that we're used to. Symmetry means same on both sides. So in this case, it's going to be something that we can reflect. So we have A equals B. So if A equals B, then B equals A. And finally is our transitive property. Now, I will be honest, this one does cause a little bit of confusion. But if you put in a note that this is essentially just double substitution, it works out really well that way. So the transitive property basically works if I substitute A in for B and B in for C. So let's word it out. So we have A equals B. All right. If A equals B and B equals C, then that means A will be equal to C. Now again, like I said, you could just consider this a version of the substitution property. Because again, if we look at substitution, it says if A equals B, then A may be replaced by B in any expression or equation. And then we also have if A equals B, then B equals A. So that indicates that B may be replaced by A in any expression or equation. So if we look at our transitive property, A equals B and B equals C. So in this instance, I am going to substitute A in for B in this expression here, and I end up with A equals C. You can also write it in the more streamlined version of A equals B equals C, but that can be more confusing. So keep it straight here. If you like A equals B equals C, that's perfectly fine as well. Now I'm sure you're all wondering why on earth we would need this information and how we're going to use it. Well, we are going to use it to complete our two-column proofs so that we can justify steps in solving an equation. So on the left-hand side of our two-column proof, we are going to list the statements, which are just the steps. What did we do? And then on the right-hand side, we're going to list the reasons. Why did we do that? What rule did we follow? There are 4 things we can use for reasons. We can use our postulates, such as our angle addition or segment addition postulate. We can use definitions, such as the definition of midpoint, meaning the 2 segments will be congruent. We can use theorems, and we haven't gone over many theorems yet, but we will. And we can also use properties, which are just a more in-depth version of the definitions. So let's go ahead and use that information to complete a couple of algebraic proofs. So for these examples, they already gave us all the statements. We're going to give the reasons. So the given information will be in the top line, and what they want us to prove will also be there as well. The first lines will always be your givens, and you're hoping that the last line here is going to be what you're trying to prove. So first off, 4x minus 1 equals 27 was given to us. And the next line they give us is 4x equals 28. So we have to ask ourselves, how did we get from line 1 to line 2? And we did that by adding 1 to both sides. So again, remember, anytime we do something to both sides, that's one of our properties of equality. We added 1. So this is our addition, property of equality. You can say POE, but I would prefer it first you write property of equality. And then we have from 2 to 3. So we had 4x equals 28, and then we end up with x equals 7. So we ask ourselves again, how did I get from step 2 to step 3? And I did that by dividing by 4. So I'm going to go ahead and make this little note. Normally you would not have to do this, but it's a good idea to do at the beginning. And we call that our division property of equality. Now notice on my last line, I'm including my last reason, not saying, oh, I proved it. Okay. How did I get to that step? That's all you're putting here. Which property, which rule? So number 2, given a divided by negative 6 plus 2 equals 5, they want us to prove that a is negative 18. So again, first line, we copy our given, a over negative 6 plus 2 equals 5, and that is our given. Our next line says a over negative 6 equals 3, so we subtracted 2 from each side. So that's our subtraction property of equality. And then finally, we go from a over negative 6 equals 3 to a equals negative 18. To get rid of a denominator, you're always going to multiply by the denominator. So we end up with the multiplication property of equality. it is important that you do put the full name during your notes so that you know what you have there. Number 3, it says given -9 times 2x minus 3 is equal to 63. And they want us to prove that x is -2. Now, there are multiple ways we could do this, and in fact, we could probably do this problem in one fewer steps than they've given us here. However, we're going to go with the steps they've given us. So from number 1 to number 2, we can see that -9 times 2x minus 3 became -18x plus 27. So they distributed there, so distributive property. We go from -18x plus 27 equals 63 to -18x equals 36. So in this case, we subtracted 27 from both sides. And finally, we end up with x equals -2. We got from step 3 to step 4 by using the division property of equality. Number 4, given 6x plus 7 is equal to 8x minus 17. We want to prove that x equals 12. So again, first line is our givens. Second line says 7 equals 2x minus 17. And again, we need to make sure we notate how we got there. So it looks like they subtracted 6 from both sides. So they did the subtraction property of equality. Then they added 17 to both sides. So addition property of equality. We get x equals, or 12 equals x. Sorry, from there, that's our division property of equality. And finally, we flipped it to x equals 12. That's going to be the symmetric property. Last one, number 5. Given -7 times x plus 2 plus 4x is equal to 6 times 2x minus 4. They want us to prove that x equals 2 over 3. So we have our givens on the first line. And here they distributed. So we have -7x minus 14 plus 4x. So that's our distribution property. Distributive. And then we have -7x plus 4x to combine to give -3x. In this instance, we're going to call this combining like terms. So we're going to combine like terms. We have to do that. Our next line states that we have -15x minus 14 equals -24. They moved the 12x by subtraction. So we have subtraction property of equality. Then they added 14 to both sides to get -15x equals -10. So that's our addition property of equality. And finally, they divided both sides by -15 to get x equals 2 over 3, using, again, the division property of equality. So those are our notes for algebraic proofs. Please remember, we're going to be doing these over and over again for at least the next several weeks, and probably for the rest of the year. So please make sure that you have your notes completed and that they're ready to go to turn in. Have a good evening, guys. Be safe.